Hi everybody, my name is Mark Mandel and I'm a developer advocate for Google Cloud for Games. Today, I want to talk to you about multiplayer games with Google Cloud Game Servers. So let's get stuck in. So to set the stage, I want to talk about exactly the type of multiplayer games that we're talking about today. So that's your fast-paced, real-time multiplayer games. So maybe you've played something like Fortnite or Overwatch or Rocket League. It's these kinds of fast-paced, real-time games that I want to talk about today. Now, a very common pattern and a very common solution for running these types of games is what's called dedicated game servers. So a dedicated game server is a full simulation of what's happening inside a game hosted somewhere on the internet. And all the players that are playing that game will connect from their clients to that dedicated game server. Each player will send information like, hey, I'm moving forward, or any other actions that they're doing inside the game. And it's up to the dedicated game server to work out exactly what's happening. Quite often they'll do full physics simulations, work out who has hit whom, who's run into what, and the effects of everything else that's happening inside the game, and then coordinate sending that information out to all the players that are therefore playing. There's a variety of reasons why this is particularly useful, but the most important one right now is that it allows you to have control of the latency aspect of the gameplay experience your players are going to have. A very fast-paced game may have a requirement for latencies under 50 milliseconds between the client and that dedicated game server. So having control over the geographic region that you can put that dedicated game server means that you can measure and ensure that that player has that kind of latency requirement met, and all the players that are playing that game session can also have that same latency requirement met as well. And everyone has a great game experience. So dedicated game servers are really useful for this kind of very fast-paced online multiplayer game. However, they're really easy to set up just one of them. That's not particularly hard. However, if we want to work with, say, a global player base, right? Maybe you have a hit game, you have 1,000, 2,000, 10,000, a million players, something really cool like that. You're going to have game players that exist all around the world, which also then means that you're going to need dedicated game servers also all around the world. And they're going to scale up at different times. You're going to have different requirements based on sleep patterns and time zones. And so orchestrating this in a global environment with lots and lots of these dedicated game servers, again, 10,000, 20,000, 100,000 of these game servers around the globe, is a complicated thing to get right. So how do we do that on Google Cloud? So let's take this from the foundation level. A project you're probably all very familiar with by now is Kubernetes, but Kubernetes is actually a great foundation for this. So not only do we have the open source aspect of Kubernetes, we also have the managed aspect in something like GKE. So you can come to Google Cloud, run your GKE workloads. But if you have a player base maybe somewhere that isn't so well represented or isn't so well supported, you can run an open source version of Kubernetes there and still be running the same environment. This is really cool because it means then that you can ensure that your dedicated game server workload can run anywhere that Kubernetes can run. And that's great. And you can still take advantage of the awesome ecosystem of tools that exist around Kubernetes as well. So let's take this one more step further. Another project you might be familiar with, especially if you worked in the game industry for a while, is Agones. So Agones is another open source project that is built as an extension to Kubernetes so that it understands the game server lifecycle and can react to orchestrate and scale it appropriately. This was started a while ago by Google and went 1.0 in September last year, but it's particularly important because the game server lifecycle is very different than, say, a database or a web server. Game servers have persistent in-memory data while players are playing them. So you can't spin them down and spin them up as you see fit, because if you interrupt player sessions, that becomes a very bad experience. So you can't just use the standard tooling for Kubernetes. You need to have specific tooling that knows, oh, there are players playing on this game server. We need to make sure we keep it alive, even if maybe we want to scale down, maybe we want to roll out a new version, and other such things as well. And Agones comes with a whole host of tooling as well for running game servers. So let's have a look. So Agones does have a host of features specifically for running game servers. First of all, it integrates directly with the Kubernetes tooling. So you're still using kubectl, we're using custom resource definitions if that's something you're familiar with, but everything is directly integrated with Kubernetes. There's nothing special there, it's just a native extension of what Kubernetes does, so you can still use the whole host of ecosystem and tooling that Kubernetes has available to it as well. It comes with a variety of auto-scaling capabilities. It integrates directly with the Kubernetes node autoscaler, but also has a variety of both inbuilt and custom autoscaling tools that you can take advantage of. It has some integration SDKs that allows game servers to be able to expose information about themselves. Sometimes game servers take a while to spin up, so we can identify when a game server is ready, be able to get information as a game server about what's happening in the outside system, pass information backwards and forwards, and more. We have SDKs for a variety of languages, including Unity and Unreal. We also have cost optimization things built in as well. So if you're running on the cloud, you want your dedicated game servers to be packed as tightly as possible, so you only use just enough resources that you need and don't pay for anything extraneous. By the same token, if you're running, say, on-prem and you want to distribute the load so that you have more reliability for machines you're probably already paying for, we can support both of those as well. So we're really keeping that in mind with Agones as well for that dedicated game server workload and how to manage it in an effective way. Finally, we also have a host of metrics that come out of the box. Whether you want Prometheus or Stackdriver, Agones provides metrics about game server counts, health, how fast they spin up and down, and more. There's great dashboards available for Prometheus. You can get started with those right away. So that's all pretty cool. Sounds like a great product. So Agones works great for single cluster workloads, but really what we need is a solution that works for multi-cluster global workloads. And this is where Google Cloud Game Server really shines. So it is a management plane that sits on top of Agones so that we can orchestrate things at a global level, right? As we were talking about previously, if you have millions of players around the globe and you want to be able to orchestrate at that global level, this is where Google Cloud Game Servers is really going to be able to help you out. So let's get stuck into that a little bit deeper, and I'm going to show you how a lot of this works. So I want to talk to you about Google Cloud Game Server's concept so you can understand what's happening here. So first thing here is what we refer to as a game server cluster. This is nothing more than a standard Kubernetes cluster with Agones installed into it. And eventually we're going to end up registering that with the game server, Google Cloud Game Server system so that it's aware of it as well. Secondly, we have this idea called realms. So you may be running, say, multiple clusters in a certain region to facilitate, helping that user base be able to get access to dedicated game servers. So realms gives you a user-defined way of grouping together these clusters in a way that you can access them and be able to target them for certain things as well. Quite often, what you'll end up doing is coordinating, say, a certain realm that is generally sort of latency the same for a particular region, like maybe US West or somewhere in Europe, something like that. Then we have game server configs and game server deployments. So this is where actually we're going to define our fleets of game servers, because usually we want to spin up a lot of them and keep them warm because they can take a while to spin up some of these. And we're going to say, okay, our configs specify these are the containers and the fleets of game servers we want to run. We can also specify our auto-scaling rules at this point as well. And our deployments, which we'll see in a bit, is how we want to deploy that across all the clusters within our realm and globally as well. So to give you a bit of an example, let's assume we have this GameX type project. For this GameX project, we're probably going to have a variety of game server clusters. And what we're going to do actually is we're going to split it into 3 realms. We're going to have a US realm, we're going to have a Europe realm, and we're going to have a Japan realm, right? So those are the areas with which we have a player base, and we're going to split that also across multiple different types of cloud. We're going to have some in GCP, we can have some in other clouds, and we can have some on-prem as well. Really flexible, so to make sure to meet your game players where they are, which is super nice. So once we have our realm specified and we've got our game server clusters registered with each of the realms, we can then create game server deployments and configs to basically distribute or set up and tell each of our fleets across all the machines, hey, these are the game servers we want to be running on here, these are the ones we want to have available, and these are the ones we want to have auto-scaling in certain ways as well. To look at it from maybe even a different perspective, getting started with Google Cloud Game Servers is basically this flow. So first step, adopt Agones. You can actually even start with open source Agones, perfectly fine, great product, and the transition path from open source Agones to Google Cloud Game Servers is super simple. You can actually even go backwards if you really want to as well. So adopt Agones, first great step. Second step, sit down, look at where your player base is or where you think it might be, and define the realms that you want to have and those clusters that you want to have within it. Once you've got those set up, you want to register the clusters with each of those realms, and in turn that registers them with Google Cloud Game Servers. From there, define your configs and your deployments so that you're able to define exactly what game servers and the size of those fleets you want to have and how they are distributed across your entire player base, across your entire global multi-cluster system. Finally, you can then test and roll out those configs and deployments, which we'll see in just a minute. So you can actually push that out, but we can also see some dry run capabilities too, which are also super cool. Awesome. I'll tell you what, why don't we get stuck into a bit of a demo and see this thing actually in action? Does that sound good? All right, let's do that. Okay, so here I have 4 clusters already set up and ready to go. I've got 2 here. Let me get my mouse. I have 2 here in the EU and 2 here in the US. And I've also set up 2 realms here as well. 1 Europe realm, 1 United States realm. And I've already got these registered. They're already here and available, already good to go. Now, what I haven't done is I haven't set up any deployments or configurations. So why don't we go ahead and do that? So we're going to come into deployments. I can actually do some of this through Pantheon. I'm going to do some of this with G-Cloud so you can see a few different things. So first step, we're going to create a deployment. This is basically a repository for where I'm going to put all my configurations and how I can control exactly what's happening. I'm going to call this STK because the game we're going to be pushing out is an open source game called Super Tux Kart, which is a super cute game, a little racing game, super fun. Okay, so we have a deployment. It's really just like a receptacle for our configs, so super easy. So now we need to create a config that we want to put inside here. I'm going to hop over to my terminal. And I've got a config. Where am I? I'm already in my configs. Excellent. Let me get my fleet v1 gcloud.yaml. So this is what a config looks like. If you've used Agones before, it probably looks quite familiar. Here we're specifying the number of replicas we would like. Here we're specifying the image that we want for our game server. I've just put a label v1.0 so we can see like which version it is as a nice thing, but that's really it. And there's a bunch of other stuff in here. We're not going to get into it today, but ultimately that's really it. We're just got our game server container and how many we want. So we want 2 of them. So I'm going to grab that. Let's pop back over here. We're going to create ourselves a config. We're going to call that v1. Call that v1. Excellent. And actually, we just want that bit. There we go. And click create. Oh, apologies. I want this one. Sorry, we have some slightly different formatting in a couple of places. It's better. Let's get rid of the tabs and create. There we go. So that's going to create our v1 config. And we can see it down here. So far, nothing has actually been rolled out to any of the game server clusters that we have set up. We need to actually activate it and roll it out. As you can see, this gives you a lot of control. You need to make sure you need to know what exactly each step is, but it means you don't accidentally do something at a global scale, which is nice. So here I'm going to specify the default config is v1 for my deployment. And this is going to roll this v1 instance out to all of the clusters that are in my global fleet. We'll look in a minute about how to do this at a realm scale, but let's just get one out automatically to everything. So let me connect to a particular cluster. Excellent. So I can now do get game servers, right? This is now available to us because we have Agones installed. And you can see here, I have a couple of game servers, right? They're already up and running. If we want to actually look at another cluster, we can do that as well. Let's look at US2, for example. Get game servers. Excellent. We also have that ready as well. Okay, so you can see that we've pushed out everything across all the clusters. Super nice. What I'll show you as well is that one of the things that Agones also does is we need a way to indicate, hey, give me a game server, please, and mark it as there's players on it, right? We were talking about that in-memory state. We have this concept called allocation. Now, Google Cloud Game Servers, in combination with Agones open source, has a concept called multi-cluster allocation. So what that means is we have, as you saw here, we have two Kubernetes clusters within a realm for the US. So once one cluster overflows, we can move over to the other one. So let's actually look at that. I'm going to run a little shell script because this calls a gRPC endpoint, which has some certs attached to it. Here we go. So we call multi-cluster true, right? And we get a response back here wherein you can see the game server name, we can see the ports and the address, and that node name there is US1, which is what we're connected to. Actually, we're connected to US2. So let's actually go back to US1. So we can see that game server. Let me connect to the right one. There we go. We can see that allocated game server. Awesome. That's great. What I'm going to do is actually, let's run this a couple more times. And that there, you can see, again, we get another US1 game server. Now, this is where the magic really happens. If we do this one more time, we're actually sending this request to the US1 server. It's going to go over to the US2 cluster and say, hey, there wasn't any here on the first one, so let me grab some from the second. Super nice. And this is where like the power of realms really comes in, because once you have a realm, you can refer to a realm and say, hey, any of these clusters, can I please have a game server? And it's able to hand you one back from any that still have capacity. So let's actually play a game. We're gonna let's grab one of these that is currently allocated. Let's grab this one. And we'll leave some allocated game servers lying around too, because that's gonna be useful later on. Okay, so we're gonna run SuperTuxCart. We'll say online, enter a server address. We'll paste that in. Nope. Oh, I hit the wrong button. Let me grab that IP import one more time. We're going to grab the top one. Yoink. Paste. Better. Okay. So that's cool. We're connected now. That's awesome. And what we're also going to do is run a bunch of agents. We're going to run a bunch of AI bots so they can also play along with us. Oops. I keep doing that. Paste that one more time. There we go. Cool. So if we have a look here, we can see we have 4 bots. Let's start our race. I will be that one, and we'll play in that one. I like that one quite a lot. So this is going to connect us to the dedicated game server that's running on a cluster that's running on the US East side. US West? I forget. I always forget which side I'm on. Close to where I am in San Francisco, so that we can have a good gameplay experience. This game server is all set up and ready to go thanks to the power of Agones, and we've had that fleet also constructed, so we have the global fleet as well across all these clusters. So this is running some AI agents locally as well. You can see this is a super cute game where we're playing a very silly racing game. I'm not going to play it for too long. Oh, I'm actually winning today. Okay, I don't want to put it down, but you can see what's going on here, and I'm able to play with a variety of bots that are going to lap me in just a sec. Here they are. Okay. So that's pretty cool. So we can actually see a game playing, which is really awesome. Let's shut that down. We'll shut that down as well. Now, we'll have a look at one of the really nice features here. If we have a look at our game servers, you'll notice one of them is now ready. We can see that actually only recently got updated. And that's because when you play a game of SuperTuxCart and everyone connects and then disconnects, SuperTuxCart's going to shut down. It's done. The game session's done. Agones and the fleet that's been defined by Google Cloud Game Servers is telling us that we always have to have 2 ready, or at least 2 available or on the go at least any given point in time. So one goes away, Agones is going to bring that back, right? Very similar to if you're looking at a deployment or looking at, say, a pod. Okay, so that was fun. Let's take this one more stage further, which is let's look at how we can do things like there's a new version that we also want to roll out. So in this particular instance, we have a new version we want to roll out. Let's go back to our configs. And Fleet V2, we're going to do this through gcloud. So we'll grab the gcloud YAML. And here we're going to say, okay, you know what? 2 game servers, not enough. We're going to say 5. We're going to put a 2.0 version on it. Maybe at some further stage, you might actually have a completely different container. But what we're going to do is we're going to say, hey, you know, I just want this to be in Europe. I'm just going to test this in Europe, make sure it works in Europe, and then once it's fine in Europe, I'm going to push it out everywhere else. So what we can do is we can have this thing called an override that will specify that, hey, in Europe, we only want a particular config version. We're going to make this a v2 config for this particular instance. And that will then tell our system that, you know what, leave the v1 alone in everywhere else around the world, but in Europe, do this very special thing. So let's do that. So gcloud beta game servers game servers config. Oh, perfect. I have it right there waiting for me. So that's going to create us a, oops, that's not right. v2-gcloud. Get that correct. Configs create deployments, fleet config file. Oh, I know why, because I'm in the configs folder. Doing stuff live is always fun. There we go. So that's going to create the v2 config. Awesome. Super handy. Again, like you saw before, that's not going to roll anything out. So now let's do a beta game servers deployments update rollouts. There we go. So what this is going to do is take that override file and it's going to say, hey, we're going to do an updated rollout, but what I want you to do is change the override so only the v2 happens in Europe. Now here's something really cool that I really like. You see this dry run here? If I hit that, what that's going to do is say, oh, I'm going to tell you everything that's going to happen before it happens. So here we can see v1 is still being applied to the US. v1's here, still being applied to the US. v2, though, is coming into, where are we, Europe. Here we go, EU and EU clusters. So we can actually see with certainty that the EU clusters are happening exactly what it is we want them to do. So let's just no dry run that. Update our rollout request. That's running. Awesome, that's done. So if we now look, say, at one of our EU clusters, grab that. We get our game servers. They're up and running. You can now see they're the v2 version, and we have 5 of them. But if we come back to our US clusters, let's grab this one here. Oops, there we go. Let's write the right thing. kubectl get game servers. We can see here we still have v1. There's only 2 of them. Everything was left as before. So we can do some like A/B testing, check out different things in different regions, have some control of how we want these things to roll out as well. Okay, one last thing I want to show you as well. So let's say we're like, this is awesome. We now love everything that's happening inside here. What we actually want to do now is roll that out to everywhere. So let's go over here. I'm going to do it through Pantheon because it makes life really easy. We're going to manage our rollout. So you can see here is another way of looking at our override. We're actually going to get rid of the override and say v2. Send it everywhere, please. Thank you so much. Okay, so that's going to send that out everywhere. If we're still connected to the right cluster, which I believe we are, if we have a look over here, we're going to see something really interesting. So here you can see here's the v2 fleet. That's all spun up, ready to go. That's all really cool. So one interesting thing, you can see that allocated game server from the previous fleet still exists, right? Again, because players are playing on this particular game server, we don't want to shut it down. So until that is specifically shut down, that is never going to go away. Very important as we update things, as we scale appropriately, as we change stuff within our system, we need to make sure that we never change this aspect. Okay, so this all sounds great. I'll tell you a little bit more. So it's worth noting that Google Cloud Game Servers is going through a staged release process. So what does that actually mean? So the phase 1 beta, it's out right now. Please take advantage, go use it, it's great, is GKE only. So you can only run on Google Cloud at this point in time. That being said, Alpha, which is coming really soon, is going to be phase 2, which will be supporting our hybrid multi-cloud on-prem solution. So you can make sure that you run your dedicated game servers anywhere you need to run. So we're going to keep on moving. We'll be looking at moving to GA very soon on GKE as we move forward with this product, but we'll be working along that as well to be supporting those hybrid multi-cloud type scenarios as well. Super useful for your dedicated game server workloads. So If that sounds particularly interesting and you want to learn more, please go to cloud.google.com/game servers, where you can find all the information that you want to find out about Google Cloud Game Servers, as well as links to Agones, links to examples, and more documentation. We're actively working on everything about the Getting Started experience, so you can also expect lots of great stuff there today. Awesome. Well, thank you so much for hanging out with me today. I really appreciate you taking the time, and I hope you found it a valuable experience to hear about Google Cloud Game Servers.